Beautiful, right? The fireworks exude a dazzling brilliance in the night. But you may be wondering whether the process of setting off fireworks is considered combustion, because it is more like an explosion than burning. You're right, it's about the other part of the combustion, which is the reaction speed. Spontaneous, rapid, and explosive combustion are three combustion reactions that mainly show the reaction speed. The spontaneous combustion reaction generally occurs at room temperature and takes a long time. Rapid combustion is the reaction in which a large amount of heat and light are produced in a short time. Explosive combustion is a very fast reaction in which a large amount of heat, light, pressure and sound are produced, such as the explosion from the spark plug in cylinder engine by air-fuel mixture and the main item of today, fireworks. Our common fireworks are divided into two categories: consumer fireworks, handheld fireworks, which is the smaller one, and display fireworks. In general, the most common consumer fireworks is the handheld firework, as known as sparkler, and it is also a smokeless firework. It is rated as the least dangerous firework. The sparkler is generally composed of oxidizer, fuel, combustible binder and metal. For the oxidizer, it can produce the oxygen to burn the mixture, which usually is the nitrates, chlorates, or perchlorates. One of the oxidizer's nitrate consists of metal ions and nitrate ions. Nitrate will release 30% oxygen to form nitrite and oxygen. The equation for potassium nitrate is as follows. Under combustion, 2 potassium nitrate solid will form 2 potassium nitrite solid and 1 oxygen gas. Next will be the fuel, as known as reducing agents, who can burn the oxygen produced by the oxidizers. Charcoal and sulfur are usually used for firework fuel, while 2 reducing agents may be combined to accelerate or slow the reaction. Therefore, the manufacturer usually will add some cornmeal to regulate the reaction, in order to expand its burning time. Moving on to the part of combustible binder, it is mainly the water-wetted dextrin, a kind of sugar, or alcohol-wetted shellac compounds. However, the sparklers may simply use the binder as the fuel, and the binder of sparklers can serve as a reducing agent and as a reaction moderator. Metal in power or finer state can produce more bright shimmering sparks when they are being heated or burnt. Different metals can form different metal ions to produce a different color of spark when we combust them. It also named as flame reactions. For example, the white color is usually produced by aluminum ion from the aluminum oxide, while the red color is usually produced by lithium ion from the lithium carbonate compound. Similar principle for other colors. Now, you know all the parts of sparklers, and let us combine them to create the sparklers. First, mixing the chemicals, which include oxidizer, fuel, combustible binder, and metal power, with water to form a slurry that can be coated on a wire by dipping or poured into a tube. Once the mixture dries, you have a sparkler. When we burn the sparkler, the aluminum, iron, or magnesium dust or flakes may be used to create the beautiful shimmering sparks. A variety of chemicals can be added to create colors. The fuel and oxidizer are proportioned along with the other chemicals, so that the sparkler burns slowly rather than exploding like pyrotechnics. Although handheld firework is fun, remember to completely soak the fairy sticks with water before throwing them away in the trash can, otherwise it may cause a fire. Next, the large-scale fireworks we often see, which is the display fireworks or the aerial firework. Chemical involved is basically the same, but the components are different. Unlike sparklers, the aerial firework has a shell, and it has 4 parts. First, the container, which is usually pasted paper and string formed into a cylinder. Second, the stars, who are spheres, cubes or cylinders of a sparkler-like composition. Third, the bursting charge, which is the firecracker-like charge at the center of the shell. Fourth, the fuse. It provides a time delay so the shell explodes at the right altitude. Located just below the shell is a small cylinder that contains the lifting charge. Simple shells consist of a paper tube filled with stars and black powder. Stars come in all shapes and sizes. For example, the size of a pea or a dime. Next, the stars are poured into the tube and then surrounded by black powder. When the fuse burns into the shell, it ignites the bursting charge, causing the shell to explode. The explosion ignites the outside of the stars, which begin to burn with bright showers of sparks. Since the explosion throws the stars in all directions, you will get the huge sphere of sparkling light that is so familiar at fireworks displays of New Year countdown celebrations. Modern fireworks can burst into hearts, smiley faces and even a representation of the planet Saturn. The shape comes down to the construction of the fireworks shell, container, and the arrangement of the exploding stars, pyrotechnic pellets, within them. As aerial shells are often spherical, they tend to explode symmetrically. Arranging the stars into the desired shape on a piece of card within the shell makes them explode outwards in that pattern. Manufacturers also use multi-break shells that have different compartments inside them, often with stars of various colors and compositions. When these are placed and fused in a specific order, they will explode in sequence to create recognizable patterns and shapes in the sky. However, it's not an exact science. Many displays will fire several copies of the same firework at the same time, so that at least one of them creates the desired shape in the audience's line of sight. That is the all of today video. Thanks for watching. Hope that you learned some things from this video, and see you guys next time.